Okay, so we are going to do 8.1, new chapter. Obviously, with new chapters comes a lot of new vocabulary, but we're going to be talking about graphing ax squared. So this is part of the functions that we were talking about in chapter 7. We're going to talk about what are the characteristics of a quadratic function, especially when it comes to the graph, and identify those characteristics and graph these equations. So a quadratic function is a nonlinear function that can be written in standard form. We went over standard form before. It's right here, standard form. And we actually factored it and multiplied with it and did all kinds of things. It's a U-shaped graph. And that U shape you can see right here. This is called a parabola. So the word is right here. It's also right here. But it's a U-shaped graph that is called a parabola. So the lowest point on the parabola, we're going to call that the minimum, but we're going to get to that later. This is where the graph is decreasing because you're always going from left to right when you're reading a graph. So this is where the graph is decreasing, and this is where the graph is increasing. And where it looks exactly identical, like if I put this point here and I put this point here, in where it looks identical, this is called the axis of symmetry. So from here to here, it's the same distance as it is from here to here, the axis of symmetry through the vertex. So the vertical line divides the parabola into two symmetric pieces. So if you take a look at it, you see this side right here. This is the mirror image of that. And that's what the symmetry is. So let's take a look at some of the functions here, or some of the things. I pre-colored this because I didn't want to make this video like 25 minutes or something. So I pre-colored it. This is what we would call the parent function right here. This is where you have f of x equals ax squared. So that's your parent function. It's that green line right there. But if it's bigger than 1, such as f of x equals 4x squared, then you would be looking at a vertical stretch. And what I mean by stretch is you're stretching the graph way out. Okay? But then if it's actually less than 1, but not equal to 0, but less than 1, then you're going to have like a wide, what we call shrink. It's going to shrink the graph. So just to know the difference between these, vertical shrink, that's this one right here, and a vertical stretch, that's that one right there. Okay? So the same thing can be true if you have a graph where maybe it actually equals a negative. So this would be like saying f of x equals negative ax squared. It's the same as the parent function. It's just a negative, which means now my u goes down. My parabola goes down. So the same thing is true though. You still have a vertical shrink and a vertical stretch. So your vertical shrink and your vertical stretch, which I think I made, yeah, I made it in pink. Okay, so when you have your vertical stretch, the number is less than -1, so it'd be like -5, -10, -100, whatever, just less than -1. And then you would have your vertical stretch. Okay, so that's a lot of terminology to take in for a second. If you need to, pause the video so you can take a look at this and wrap your head around what I was talking about. But we're going to do some examples. So we want to take a graph and we want to talk about what are the attributes of this graph, like what is it doing. So consider this graph of the quadratic equation. Using the graph, you can identify characteristics such as the vertex, axis of symmetry, and the behavior of the graph. Is it increasing, decreasing? What's it doing? So if you take a look at this one, you can see this is decreasing all the way until this point, which is your vertex, and then it increases. And the axis of symmetry just means that this is mirrored on either side. Okay, so identify the characteristics. So this is where the function is decreasing. This is where the function is increasing. Okay, vertex, right down here. So your axis of symmetry, this is your axis of symmetry. And this is my vertex. Okay, so identified characteristics of the function. This vertex would be called a minimum later on, but we're not getting to that just yet. So if you take a look at this graph, it's upside down, a little bit different. So now this is where it's increasing, and this is where it's decreasing. That means the values get lower and lower, the values get higher and higher, up to a point where this is a maximum at the vertex, and you have your axis of symmetry. So these are the attributes of this particular quadratic function. So take a look then at graphing and then compare it to the actual graph of what we would call the parent function. Let me move this so I can have both of them in range at the same time. There we go. So if I was doing f of x equals x squared, you can just do a quick little table. It's always going to look exactly the same. A parent function is parent function. So you have x and then your y value. So let's say we plug in 0, 1, 2. And remember that this is going to be the same for -1 and -2 as well. It's just going to be the opposite sides. So you could actually even have plus or minus here, if that hopefully doesn't confuse you too much. But if I plug a 0 in here, 0 times 0 is 0. 1 times 1 is 1, or -1 times -1 is 1. 2 times 2 is 4, or -2 times -2 is still 4. So you can see your graph starts to take shape. And let me see if I can see the 4. There it is. And 1, 2, 3, 4. You can see the symmetry. I'm going to actually go to 3 on this one because it'll take me up to 9. So 3 times 3 is 9. So if you want to add 3 plus or minus 3, you'll get a 9 here. That's all I did was just add that little bit right there. That. So you can do the 9. So 3 and then 9. And you get a nice U shape, -3, 9. When you connect all this, your U shapes don't have to be perfect. It's very rarely going to look like they do up at the top. But that's your graph. So what happens when I multiply it by 2? Well, I take the exact same thing and I can come up with a table if you need to, or you can plug this into a graphing calculator and see the values. But 0 plus or minus 1 plus or minus 2 plus or minus 3. So take a look at this. This is actually I'm going to pull this up for just a second. This is actually the same exact thing except for multiplied by 2, right? So 0 times 2 is still 0. 1 times 2 is 2. 4 times 2 is 8. And 9 times 2 is 18. So you can see the graph went up a lot faster. So let's graph what we can on that. So I still have my 0, and that's fine. But then you'll notice this is actually at 2 and 8. So 3 is at 8 and 8. And I won't be able to do the 18. And there's my graph. So you can see the difference between the two of them. One got skinnier and it rises faster. Why? Because it simply is multiplied by 2. So it increases faster. It decreases faster. And that's what happens to the graph. Okay, let's try this one. Now, this one is going to be a little bit the opposite. So I already did this one right here, right? We're going to use the same exact values. So, no, we're not. I take that back. Well, we are for that. So this right here, we'll try to make it smaller, is going to have 0, plus or minus 1, plus or minus 2, plus or minus 3, 0, 1, 4, and 9. We already did that. We did that on this problem right here, just to put our parent graph in here. So 1 and then 2 was 4 and 3 was 9. And you just mirror it. 1, 2, and 3, 9. Okay, our original graph, which we call the parent function. I'm actually making my U's really nice right now. I'm actually shocked. So if I actually do this and I multiply it by 1/3, well, you're going to get negative 1/3, sorry. You're going to get the graph going down, first of all, but secondly, dividing 4 by 3 isn't going to always give you the easiest answers to graph either, but you can do that. So if you have x, y here, 0 times 1/3, negative 1/3 is still 0, because anything times 0 is 0. And 1 times negative 1/3 is going to still be negative 1/3. You can see how that might be not easy to graph on a graph like this. 2 is going to be negative 4/3. And 3, when you have 9 divided by 3, that's 3. So it's negative 3. And you can see you can get some of those values. So when you see something like this, I'm just going to give you a little hint right here. When you see something like this, if you actually see the 3 here, use multiples of 3. So like use 0, 3, and then use 6, 9, so that you get nice even numbers when you do your multiplication. Okay, so if you use multiples of 3, if we actually followed that, you would have 0, 3, 6, 9, and you would be looking at doing, remember this one is going to be negative 3, 0, 6 times 6 is 36, divided by 3 is 12, and you can see that you get answers that are nice even numbers. 9 times 9 is 81, 81 divided by 3 is 27, and again you get nice even numbers. So if you were looking for even numbers, use the multiples of whatever the fraction is. If it doesn't matter to you, or in this case the graph isn't that big, you don't have to do that. So let's graph this. So 0, 1 is going to be negative 1/3. So this is what I was talking about, how it's going to be so tiny, like so tiny. It's just by start of it. Negative 4/3, that's about 1 1/3. So 1 1/3, again, really tiny. That was for 2, actually. So 2, 2, and then you have 3 and 3. And then if we were going to do 4, it would be 16/3, which equates to about 5. Well, 16/3, but that equates to about 5 and I think 1/3. So 5, 1/3. It's really hard to see this on a graph. Like 1/3. And you can see it gets a little wider, and then it just keeps going after that. So you can see the differences between the two. Much wider, increasing and increasing and decreasing, with this being a maximum now. Okay, so hopefully that answered all your questions and everything you ever wanted to know about this, because this is just moving up or down, going wider or skinny. So you got your shrink and your stretch, your shrink and your stretch, okay? And on our next lesson, we're going to be talking about how to move the graph from side to side. So we're just going to keep adding to how we graph a quadratic, and we're going to do this as our lesson. If you have any questions, as always, please make me aware. Let me know.